Have you ever just stopped and really thought about that question? I mean, we're surrounded by it constantly. Music, people talking, traffic. The whole world is just buzzing with sound. But if you had to actually explain what it is, what would you say? Let's really dig into that. So today, we're going to do something kind of cool. We're going to follow a single tiny sound wave on its incredible adventure, all the way from the moment it's created to the second it lands in your brain. It's a trick that's over in a flash, but trust me, it is way more amazing than you probably think. All right, so here's our roadmap. First, we're going to see how a sound is even born. Then we'll follow it as it travels through the world and eventually into our ears. We'll figure out what makes a sound high or low, loud or soft, and what makes some sounds pleasant and others just noise. And we'll wrap up by exploring a whole secret world of sound that we can't even hear. Okay, first stop on our journey. Every single sound you've ever experienced, I'm talking everything from a tiny whisper to a massive thunderclap, it all starts the exact same way, with a vibration, a shake. That's it. And this is the absolute key to understanding it all. Sound isn't a thing. It's not like a little particle flying through the air. It is pure energy. It's the energy from a vibrating object that gets passed along. And when that energy finally bumps into your eardrum, your brain performs this little magic trick and interprets it as hearing. I mean, just think about it for a second. When you ring a bell, the metal itself is physically shaking. You can see a guitar string blur when you pluck it. That's it vibrating super fast. The cone in a speaker is just pushing and pulling air. Heck, the sound of my voice right now, that's just a couple of tiny flaps in my throat shaking around. It all comes back to vibrations. Hey, you don't have to take my word for it. Try this with me right now. Go on, put your fingers gently on your throat, kind of right over your voice box. Now, just say your name or hum a little bit. Feel that? That little buzzing sensation? Yep, that's it. Those are your vocal cords vibrating, creating the energy that is the sound of your own voice. Kind of neat, right? Okay, so our sound energy has been created. A vibration happened. But now what? How does that energy get from a ringing bell all the way across the room to your ear? Well, it's gotta travel. And this is where the journey gets really interesting. This is like the number one most important rule of sound. It cannot travel through nothing. So all those sci-fi movies with the giant explosions in space making a huge kaboom, yeah, that wouldn't happen. In the vacuum of space, it would be totally silent because sound needs stuff to travel through. It has to have particles to carry its energy along. And that stuff it travels through, that's called a medium. The most common one, obviously, is the air all around us, which is a gas. But sound is not picky. It'll happily travel through liquids like water, or even right through solid objects like a wall or a table. And check this out. The medium doesn't just give sound a path, it actually sets the speed limit. And the differences are huge. In air, sound moves at about 340 meters per second, but in water, it's way faster, 1,500. And in solid steel, it's a mind-blowing 5,000 meters per second. It's all about how close the particles are. In steel, they're packed shoulder to shoulder, so they can pass that vibration along almost instantly. All right, so our sound wave was born from a shake, it raced through a medium, and now it's finally arrived at its destination. That incredibly complex and kind of strange-looking piece of equipment on the side of your head, the human ear. What happens inside your ear is honestly like a tiny biological machine. First, the sound wave goes down your ear canal and smacks into your eardrum, making it vibrate. That vibration then gets passed to the three smallest bones in your entire body, the hammer, anvil, and stirrup. And yes, they're called that because they literally look like tiny versions of those things. They act like little amplifiers, and they send the now stronger vibration into a snail-shaped, fluid-filled thing called the cochlea. From there, tiny little hairs turn the vibrations into electrical signals that finally shoot up to the brain. It's an insane chain reaction. So, the brain gets the signal. But how does it know the difference between, say, a tiny bird chirping and a giant bass drum booming? Well, it's because every sound has its own unique fingerprint, its own personality, made up of a few key traits. First up is pitch, high notes and low notes. This is all about the speed of the original vibration. Really fast vibrations make waves that are squished close together. Our brain hears that as a high pitch, like a whistle. Slower, lazier vibrations make waves that are all spread out, and we hear that as a low pitch, like a deep hum. Next, you've got loudness. This is all about the power, the sheer force of the sound wave. We measure this in something called decibels. So a normal chat is about 60 decibels. Heavy traffic can get up to 80. A jet engine taking off nearby, that's a painful 130 decibels. And you really got to be careful, because anything over 85 decibels for a long time can start to permanently damage your hearing. So this brings up a really interesting question. Why do we love the sound of a piano, but hate the sound of a jackhammer? You might think it's just personal taste, but it turns out there's actually a bit of math behind it. It really all boils down to one simple thing: patterns. See, music is created by vibrations that are regular and repeating. They have a structure that our brains find really satisfying. Noise, on the other hand, is just chaos. The vibrations are random, messy, and all over the place. And our brains interpret that lack of a pattern as unpleasant and jarring. And our brains interpret that lack of a pattern as unpleasant and jarring. And when our world is just filled with too much of that unpleasant, loud, chaotic sound, you get noise pollution. It isn't just annoying, it can actually cause stress, mess up your sleep, and like we said, lead to hearing loss. It's one of the big downsides of our busy, modern world. So we've traced the journey of a sound that we can actually hear. But believe it or not, our adventure isn't quite finished. Because maybe the most mind-blowing part is the world of sound that's all around us, all the time, that we are completely and totally deaf to. Here it is. This is our limit. A healthy human ear can pick up frequencies from about 20 vibrations per second, or 20 hertz, all the way up to 20,000 hertz. Now, that sounds like a pretty big range, right? But in the grand cosmic scheme of things, it is just a tiny, tiny slice of all the sound that's out there. Anything above our 20,000 hertz is called ultrasound. And this is where animals and our own technology get actual superpowers. Bats use it to see in the dark with echolocation. We use it for sonar to map the deep ocean floor. We even use it in hospitals to look inside the human body without ever making a cut. And yep, a dog whistle? It works because your dog can hear those super high frequencies that are completely silent to you and me. And that kind of leads us to one final, pretty wild thought. Our entire experience of the world comes through these very specific, very limited senses. We now know there's a whole universe of sound that's happening right now that we can't hear. It really makes you stop and wonder, doesn't it? What else is flying right past us, completely unnoticed?